Hello everybody, welcome into another lesson. So today we are going to talk about finding the inverse of a 3 by 3 matrix. And when I say a 3 by 3 matrix, this method works for really any order of a square matrix. You can use this on a 2 by 2, but you're probably doing a little more work than you need to. But this will work on a 4 by 4, a 5 by 5, what have you. So what we have here is you have some matrix A with your various coefficients on your x, y, and z terms in each of the three rows. This is a 3 by 3 matrix. Finding the inverse of a 3 by 3 or greater matrix is not quite as simple as finding the inverse of a 2 by 2 matrix, because the method doesn't involve finding the determinant of the matrix. Yes, we can find the determinant of a 3 by 3 or greater matrix, and we're going to do that a couple lessons from now, but this method does not involve that. So what you want to do is set up your original matrix on the left-hand side, make an augmented matrix with the identity matrix on the right-hand side. This is a 3 by 3 identity matrix with ones going down the main diagonal, all other entries 0. The idea is that what you're going to do to get the inverse is perform row operations to get the identity matrix on the left-hand side, and then get a new matrix on the right-hand side, and that new matrix on the right-hand side is going to be your inverse matrix. And notice I changed the coefficients to reflect that you could have different coefficients. Some people thought they were being funny and just thinking they could take the left and right places and switch them around and you have your inverse, and no you don't. That's not how that works, unfortunately. So let's get into a few examples here of finding inverse matrices. So let's say we have some matrix A. It's going to have entries 1, 1, and 1, 3, 5, and 4, and then 3, 6, and 5. So here's your original matrix, matrix A. You have entries 1, 1, 1, 3, 5, 4, 3, 6, and 5. Well, the first thing I'm going to highly recommend you do is turn this into a turn this into an augmented matrix, where to the right of the line of augmentation you have your identity matrix for a 3 by 3 matrix. So in the top row you'll have 1, 0, 0. Second row you'll have 0, 1, 0. Third row you'll have 0, 0, 1. That is going to be, to the right, that's the 3 by 3 identity matrix, again with ones going down the main diagonal, all other entries 0. We need to perform row operations to make the left-hand side become the identity matrix, or another term we can use for that is reduced row echelon form. The identity matrix is always in reduced row echelon form. And then the right-hand side will become our inverse matrix after that. So let's go ahead and perform some row operations here. The first thing we probably want to do is get the first entries in rows 2 and 3 to become 0. Well, I think it's probably in this case, it don't really matter. Let's kill two birds with one stone. Let's take -3 times row 1, add that to row 2, and then take -3 times row 1, add that to row 3. So we can do two row operations at once. If we do that, what you're going to get is you'll leave row 1 alone temporarily. You'll have 1, 1, 1, And then to the right of the line of augmentation, you'll have 1, 0, 0. Now, if I take negative 3 times row 1 and add it to row 2, so negative 3 plus 3 is 0. Negative 3 plus 5 is 2. Negative 3 plus 4 is 1. And then, okay, negative 3 plus 0 is negative 3. 0 plus 1 is 1. 0 plus 0 is 0. Okay, now we need to do negative 3 times row 1, add that to row 3. So negative 3 plus 3 is 0. Alright, negative 3 plus 6 is 3. And then negative 3 plus 5 is going to be 2. Alright, now negative 3 plus 0 is going to end up being negative 3. Then 0 plus 0 is 0. 0 plus 1 is going to be 1. Alright, so on the left-hand side, we have the first two entries as 0. The next thing we probably should do is get the first digit. Actually, no, you know what? I thought better of it. Why don't we go ahead here? Why don't we make the third digit in rows 1 and row 3 a 0? Okay, why don't we do that first? It might make our lives a bit easier. So, if we make the third digit in rows 1 and 3 a 0, if we take negative of row 2, add that to row 1, and then if we take, let's see, if we take negative 1/2 of row 3, add that to row 2, we can do that. So to make the third digits in rows 1 and 2 a 0, I could take negative of row 2, add it to row 1. No, I just thought better of it, because I can't apply the change to this row while changing this row at the same time. Forgive me for that. I tell you what, let's just make the third digit of row 1 into a 0. So if I do that, I'll take the negative of row 2, add that to row 1, and let's see the change that we get. We'll end up with, let's see, 0 plus 1 is still 1. Negative 2 plus 1 is going to be negative 1. Negative 1 plus 1 is 0. And then let's see, negative 3 is 3 plus 1 is 4. Negative 1 plus 0 is negative 1. 0 plus 0 is 0. And then right now we're going to leave rows 2 and 3 alone temporarily. Alright, now my next focus is going to be, why don't we make the third digit of row 2 a 0? If I take negative 1/2 of row 3 and then I add that to row 2, I can make that happen. So let's set up our new matrix here. So we're leaving row 1 alone temporarily. 1, negative 1, 0. Then let's see, we'll have 4, negative 1, 0. Then, alright, let's see. 0 plus 0 is still 0. And then, let's see. Negative 3/2 plus 2, that's going to end up being 1/2. And then, let's see, negative 1 plus 1 is 0. And then let's see, negative 3 halves minus 3 would end up being negative 9 halves. Then 0 plus 1 is 1. And then negative half plus 0 is negative half. So yes, sometimes you're going to have fractions. Then we have left row 3 alone. 0, 3, 2. Negative 3, 0, and 1. Now what can we do here? Next thing I'm going to suggest is we make that leading digit in row 2 a 1. We can just take 2 times, in row 2, excuse me, make that leading digit in row 2 a 1. If I just take 2 times row 2, I can make that happen. So let's go ahead and apply the changes here. So row 1 is being left alone, 1, negative 1, 0. And then I'll have 4, negative 1, 0. All right, 2 times row 2, you'll get 0, 1, 0, negative 9, 2, negative 1, and then row 3 is left alone. 0, 3, 2, negative 3, 0, 1. Well, I got the leading digit in row 2 to be a 1. I have all other entries in row 2 I got the leading digit to be a 1. I also have all other entries in row 2 as a 0, so that's good. What I would suggest next is a couple things. We should make the second digits in rows 1 and 3 a 0. I can do that if I take row 2 and add that to row 1. That'll make the second digit in row 1 a 0. And then if I take negative 3 times row 2 and add that to row 3, I can make that second digit in row 3 also a 0. So let's go ahead and apply those transformations. Now, forgive me, I'm going to have to erase some of this, okay? Because I'm going to run out of room otherwise. So if you need this, rewind the video, feel free to go back, but I'm going to continue up here, okay? So let's see, row 2 plus row 1, so 0 plus 1 is 1, 1 minus 1 is 0, 0 plus 0 is 0. Alright, negative 9 plus 4 is negative 5, 2 minus 1 is going to be 1, negative 1 plus 0 is negative 1. And then we're going to take the negative, we're going to leave row 2 alone, actually. We can leave that completely alone since that's reduced. So 0, 1, 0, negative 9, 2, negative 1. Now, negative 3 times row 2 plus row 3 will get rid of the second digit being a 3. We can make that a 0. So 0 plus 0 is still 0. Negative 3 plus 3 is 0. 0 plus 2 is 2. Alright, negative 3 times negative 9 is 27. Minus 3 is 24. See, negative 6 plus 0 is negative 6. 3 plus 1 is 4. We almost have the identity matrix on the left-hand side. It's almost in reduced row echelon form. The only thing is now we need that leading digit in row 3 to become a 1. And we can do that by simply taking half of row 3. So if we take half of row 3, we can certainly achieve that. So let me erase some space here. I'm going to bring this down here, okay? So we'll end up having 1, 0, 0, because we're leaving row 1 alone, negative 5, 1, negative 1, and then you'll end up having row 2 left alone, 0, 1, 0, negative 9, 2, negative 1, but we're going to take half of row 3, so you'll get 0, 0, 1, 12, negative 3, and 2. So now the left side is in reduced row echelon form. You have the identity matrix on the left-hand side. This new matrix to the right is your inverse matrix. So let me go ahead and erase all this and write out what the true inverse matrix is here. Erase everything down here. That means that your inverse matrix, A inverse, is going to equal the matrix of negative 5, 1, negative 1, negative 9, 2, negative 1, 12, negative 3, and 2. So the A inverse matrix has entries negative 5, 1, negative 1, negative 9, 2, negative 1, 12, negative 3, and 2. And if you really care to, you can take matrix A times the A inverse to check your result. You should get the identity matrix. That's how you can check to make sure you got the right answer for the inverse matrix. I have 3 more. This time I truly do have 3 more. These are kind of arduous enough to do, and no, we're not going to do anything greater than a 3 by 3. There's also ways to use graphing calculators to compute inverse matrices, and once you get above a 3 by 3, that's probably a great idea. Alright, matrix A this time has entries 1, 2, 2, 3, 7, and 9, negative 1, negative 4, and negative 7. So you have another 3 by 3 matrix where you have entries 1, 2, 2, 3, 7, 9, negative 1, negative 4, negative 7. Well, what I'm going to suggest in order to find the inverse is first set this up as an augmented matrix with the identity matrix to the right of the line of augmentation. So that'll be 1, 0, 0, then 0, 1, 0, and then 0, 0, 1. So now you have your identity matrix to the right. The idea is to do the row operations to get the identity matrix on the left, and whatever you get on the right is your inverse matrix. So first thing we need to do, we can take, I would suggest we make the first digits in rows 2 and 3 both a 0. If I take negative 3 times row 1 and add that to row 2, and then if I just simply take row 1 and add that to row 3, I can make that first digit in each of those rows become a 0. So let's go ahead and see what we get here. So row 1 is temporarily left alone. You'll have 1, 2, 2, 1, 0, 0. Now, negative 3 plus 3 is 0. Negative 3 times 2 is negative 6 plus 7 is 1. And then you'll end up having negative 3 times 2 is negative 6 plus 9. That's going to be 3. Negative 3 plus 0 is negative 3. 0 plus 1 is 1. 0 plus 0 is 0. And then now, to manipulate row 3, we're going to take row 1 and add it to row 3. So 1 minus 1 is 0. 2 minus 4 is negative 2. And then 2 minus 7 is negative 5. Alright, and then 1 plus 0 is 1. 0 plus 0 is 0. And then 0 plus 1 is 1. Alright. Well, I can tell you this, we are off to a good start. The next thing I'm going to suggest that we do is we make that third digit, the second digit in row 3 become a 0? In order to do that, I'm going to take 2 times row 2 and add that to row 3. So let's go ahead and perform those row operations here. Row 1 is left alone temporarily. You have 1, 2, 2, 0, 1, 3. I guess I better put stuff to the right of my augmented line. You'll have 1, 0, 0, negative 3, 1, 0. Alright. 0 plus 0 is 0. 2 minus 2 is 0. 2 times 3 is 6. Minus 5 is going to end up being 1. And then, alright, negative 6 plus 1 is going to end up being negative 5. And then 2 plus 0 is 2. 0 plus 1 is 1. Well, now we have row 3 fully reduced. The leading digit is 1. We're finally done with row 3. What I actually suggest we do next is let's make the third digit in rows 2 and 1 both a 0. So if I take negative 2 times row 3 and I add that to row 1, I'll be able to make that third digit into a 0. Then if I take negative 3 times row 3 and add that to row 2, I'll be able to make that third digit a 0. So let's go ahead and see what we get here. So let's see. 0 plus 1 is still 1. Alright. 0 plus 2 is 2. Now negative 2 plus 2 is 0. Alright, 10 plus 1 is 11. Negative 4 plus 0 is negative 4. Negative 2 plus 0 is negative 2. And then now we're also going to deal with row 2. So 0 plus 0 is 0. 0 plus 1 is 1. Negative 3 plus 3 is 0. Alright, 15 minus 3 is 12. Negative 6 plus 1 is negative 5. Negative 3 plus 0 is negative 3. And then we left row 3 alone because, in truthfulness, it's actually already reduced. So we have fully reduced rows 2 and 3. The only thing left to do now is make that second digit in row 1 a 0. So I'm going to erase some space up here. Alright, if you need these parts, feel free to pause the video, take the notes, do whatever you need to do. I just don't want to run out of space. Alright, so the next thing to do, as I said, make that second digit in row 1 a 0. I can just take negative 2 times row 2 and add that to row 1. So if I apply that transformation, I'm actually going to bring it up here. I'll end up getting, let's see, so 0 plus 1 is 1. Negative 2 plus 2 is 0. 0 plus 0 is 0. Alright, now negative 24 actually plus 11 is negative 13. 10 minus 4 is 6. And then we have 6 minus 2 is 4. And then all other rows are left alone. And what do you know? You have now the identity matrix on the left-hand side, which is exactly what you want. This side of the augmented matrix is actually your inverse matrix. So A inverse would equal this right-hand side of the augmented matrix. You would end up with the inverse of A would be negative 13, 6, 4, 12, negative 5, negative 3, negative 5, 2, and negative 1. That would be your A inverse matrix. Entries negative 13, 6, 4, 12, negative 5, negative 3, negative 5, 2, and negative 1. So there's that inverse matrix. And again, you can check your result by taking A times A inverse. You should get the identity matrix. That's how you'll know you did it right. Okay, I just got 2 more examples, then we'll be done with the lesson. Of course, it's time for another marker. All right. Matrix A is going to have entries of negative 5, 0, 0, 2, 0, 0, then we have negative 1, 5, and 7. Alright, so negative 5, 0, 0, 2, 0, 0, negative 1, 5, and 7. Alright, so what I would definitely suggest is, here's the thing. If we notice here, in both rows 2 and 3, all other digits are 0 besides the first digit. And I'm pretty much going to guarantee this is not going to be an invertible matrix, but let's do it anyway. So to the right, you should be able to set up your identity matrix to the right of the augmented line, just to lay the stage. Now, I'm going to suggest to start with, we take negative 1/5 of row 1 to get that leading digit to be a 1. We'll deal with everything else in a minute. So negative 1/5 of row 1, apply that transformation, you should end up with 1, 0, 0, negative 1/5, 0, 0, then you'll have 2, 0, 0, 0, 1, 0, then negative 1, 5, and 7, 0, 0, 1. Okay. Well, we got the leading digit in row 1 to be a 1. We need to make the first digits in rows 2 and 3 a 0. Well, if I just take negative 2 times row 1 and add that to row 2, and then I just add row 1 to row 3, I should be able to make the first digit in each of those rows a 0. So what we're going to do here is we're going to take negative 2 times row 1, so negative 2 plus 2, well, let me write out the first row first, that might help, right? Alright, 1, 0, 0, negative 1/5, 0, 0, and then negative 2 plus 2 is 0, 0 plus 0 is 0, 0 plus 0 is 0, but then I'll have 2/5 plus 0 is 2/5, 0 plus 1 is 1, 0 plus 0 is 0. And then if I take row 1, add it to row 3, so 1 minus 1 is 0. 0 plus 5 is going to be 5. 0 plus 7 is 7. And then, let's see here, if I take negative 1/5 plus 0, I'll end up getting negative 1/5. 0 plus 0 is 0. 0 plus 1 is 1. Well, the last thing to do, make your leading digit in row 3 a 1. Or actually, no. Let's switch places with rows 2 and 3. So I'm just going to switch places with rows 2 and 3, which would end up giving me 1, 0, 0, negative 1/5, 0, 0, and then you'll end up having 0, 5, 7, negative 1/5, 0, 1, and then 0, 0, 0, 2/5, 1, 0. Because to get a matrix in reduced row echelon form, the other part of that is all 0 entries must be on the bottom row. Well, the only other thing left we can do is make that leading digit in row 2 be a 1. So if we just take 1/5 of row 2, we can do that. Let's see what we get. So you'll end up with 1, 0, 0, negative 1/5, 0, 0. Now we're taking 1/5 of row 2, so you would get 0, 1, 7/5, negative 1, 25th, 0, 1/5, and then we can leave row 3 alone, 0, 0, 0, 2/5, 1, 0. It looks like we're almost to the end. The only other thing we'd have to do is get rid of that 7/5, but we have no path forward to get rid of that third digit in the second row, and we don't have any leading digits in the third row. It's entirely 0 entries. The only way you can end up getting an inverse matrix is if you get the true identity matrix on the left. We've done all we can, so you would end up saying that this matrix is not invertible. So the matrix given to us was actually not invertible in this case, sadly. So we did all that work to see sometimes that the matrix is not invertible. You will sometimes get that, unfortunately. If you're unable to get the identity matrix on the left, that means this matrix is actually not invertible. I got just one more. It's similar but different enough where we actually could have a different result. Alright, so matrix A has entries of 1, 0, 0, 3, 5, 0, and then 2, 5, 0. Alright, so here's your matrix A, the original matrix, entries 1, 0, 0, 3, 5, 0, and then we have 2, 5, 0. Alright, so first thing, if we want to have a shot at finding the inverse, we need to set this up as an augmented matrix with the identity matrix on the right hand side. So the identity matrix for a 3 by 3 is 1, 0, 0, 0, 1, 0, 0, 0, 1. Now here it is set up as an augmented matrix with the identity matrix on the right. Well, good news is row 1's already completely reduced. We don't have to do a darn thing to row 1. Now on the other hand, we do need to do something to rows 2 and 3. We should probably make that first digit in rows 2 and 3 a 0. In order to do that to row 2, we need to take negative 3 times row 1, add that to row 2. And then to do it to row 3, we need to take negative 2 times row 1, add that to row 3. So let's go ahead and apply those transformations. So row 1 is left alone, 1, 0, 0. And then you end up having 1, 0, 0. All right, now negative 3 plus 3 is 0. 0 plus 5 is 5. All right, now 0 plus 0 is 0. Negative 3 plus 0 is negative 3. 0 plus 1 is 1. 0 plus 0 is 0. Now we're going to deal with row 3, so negative 2 plus 2 is 0. 0 plus 5 is 0. 0 plus 0 is 0. And then, okay, negative 2 plus 0 is negative 2. 0 plus 0 is 0. 0 plus 1 is 1. Well, the only thing left that we can do, a couple things left we can do, but the first thing I would suggest is we make that second digit in row 3 a 0. So if I just take the negative of row 2 and add that to row 3, I can make that second digit in row 3 a 0. So you'll end up here with 1, 0, 0. 1, 0, 0. All right, we're going to leave row 2 alone temporarily. 0, 5, 0. Negative 3, 1, 0. All right, so 0 plus 0 is 0. Negative 5 plus 5 is 0. 0 plus 0 is 0. Let's see, 3 minus 2 is 1. Negative 1 plus 0 is negative 1. 0 plus 1 is 1. The only thing left to do now is make that leading digit in row 2 a 1. Well, we just simply got to take 1/5 of row 2. Let's go ahead and take 1/5 of row 2. Let's see what we get when we do that. So row 1's good to go. We can leave that one alone. 1, 0, 0. 1, 0, 0. And then 1/5 of row 2, so you'll have 0, 1, 0. 1/5 of negative 3 is negative 3/5. 1/5 of 1, of course, is 1/5. And then 1/5 of 0 is 0. Then we can leave row 3 alone. You have 0, 0, 0. 1, negative 1, 1. We would almost have an inverse matrix, except for one thing. There is no leading digit in row 3. It's all zeros, right? Which means I'm unable to assign any type of value to z, to the z coefficient. I am unable to get the identity matrix on the left-hand side. So that means this matrix is also not invertible. And there is one more thing to discuss in general. If you have a matrix such as this or the last example, where in 2 or more rows, if you have 2 or more rows where you have 0 entries in the same spots, it's going to be a non-invertible matrix. You can have 0 entries in matrices and still get an inverse, but if you have it in 2 or all 3 rows where you have the same spots that have zeros, it's not going to be invertible. You can save yourself a lot of grief right there. I just wanted to show you this so you can understand what we were up against. So that is a good trick to use. If you have, like here, both rows 2 and 3 in the z spot have a 0. And actually, you have it also in row 3 already. I mean, in row 1. In the last exercise, both rows 1 and 2 had zeros in the y and z spots, meaning we had no way to even assign a z value or to get rid of the y and z values in the third row. So that is a way to know right off the rip if it's not invertible. But next lesson, we're actually going to use inverse matrices to solve systems of equations. Admittedly, it's not the most user-friendly way, but it is a viable method, so I do gotta teach it. So I hope everyone has a great day. Take care.